So today we'll be learning about space curves. I'm gonna try to make this a short video because space curves aren't too hard to understand. I'm gonna name this video like, let me think of a name. Uh, like what are space curves? I think that sounds good. That's like a straightforward name. So for those of you who don't understand what space curves are, look like this. Now they're not always curvy. They can make weird motions, like follow my mouse like this, like really weird, like this, go all around, all around. They're not always like a spiral, okay? But I'm gonna start with this example. So for this example, I have a line that we've been traditionally using inside of Calculus 3. This line is defined by the function negative 2t minus 1 as the x component of the line, 3t plus 2 as the y component, and t plus 3 as the z component. And I just set the domain to negative 100 and 100 so you can see the entire line. But if you represent this function in vector form, so if this wasn't a function and this was just a vector with the, I guess, definitions of with the variable t that controls it, it would be represented as this right here, vector. And I started off 0, 0 because all vectors start off at 0, 0, 0. But if I represent this line function as a vector, you can see it in the red. You can actually trace all the points on the line right here. And the thing about space curves is that they work exactly the same. This vector has a tip, and that tip is some one-dimensional point. And if you plot those points infinitely along an entire line, it creates a two-dimensional line. Wait, a one-dimensional line. Sorry, one-dimensional line. So these zero-dimensional points, right? These just points create a one-dimensional line like this. Now, what would happen if we change the values of the x, y, and z components of the line into something more abstract, like sine, cosine? Well, you get a curve like this. If I plot the vector for that curve, and I trace the vector along the curve, it actually just plots all the points. You can see that this vector just traces along the entire space curve. So basically what space curves are the same thing as your vector functions of lines right over here, except with just sine, cosine, or some weirder arctan or something like that, some weirder function in it that can describe its motion. Now, space curves, they can describe the path of a particle at any given time. They could also describe or just show you some weird graph-looking line like this. So they're actually not that complicated. It's basically, again, let me say this again, basically just think of a space curve as this line right here, your traditional function of a line that you've been using for Calculus 3 the entire time, and change up these functions. Instead of making them linear functions, you made them some weirder function like sine or cosine or t squared. T to the, like t squared. Like I can change this right here actually. Wait a second. Well, that looks fine, but let me put like t squared here or something. No, that doesn't work. Yeah, 2, 2, 3. Oh, yeah, that makes something weird. Well, you know what I mean, okay? So, if you have any questions, put it down in the comment section. I'm just going to reiterate this again. Space curves are just vector. It's called vector valued functions. They're also known as vector valued functions, where you plot the tip of the vector, the points on the tip of a vector infinitely to create a line.